Hello everyone, this is Lana speaking and I'm going to present to you the evaluation of energy harvesting ideas from radiation including radio frequency, solar, and the others. So, energy gives the ability to do work and it exists in many forms such as thermal, radiant, chemical, nuclear, electrical, elastic, and gravitational energy. During the last 20 years, the worldwide energy demands have been strongly increased, and as a consequence, the deleterious effects of hydrocarbon-based power, such as global warming, air pollution, acid precipitation, ozone depletion, and forest destructions, are increasingly apparent. In order to limit these drawbacks, suitable actions aimed at reducing the dependence on the fossil fuels are needed, such as the search for clean and renewable alternative energy sources, is one of the most urgent challenges to the sustainable development of human civilization. Energy harvesting, also known as energy scavenging or macro-energy harvesting, is the capture and conversion of small amounts of readily available energy in the environment into usable electrical energy. The electrical energy is conditioned for either direct use or accumulated and stored for later use. Moreover, the process of energy harvesting takes different forms based on the source, amount, and type of energy being converted to electrical energy. In its simplest form, the energy harvesting system requires a source of energy, such as heat, light, or vibration. Also, energy harvesting is beneficial because it provides a means of powering electronics where there are no conventional power sources, eliminating the need for frequent battery replacements and running wires to end applications. By the same token, it opens up to new applications in the remote locations, underwater and other difficult to access locations where batteries and conventional power are not realistic. Let's not forget that energy harvesting is also largely maintenance-free and is environmentally friendly. Furthermore, energy source examples include light, which is captured by photovoltaic cells, vibration or pressure captured by piezoelectric elements, temperature differentials captured by a thermoelectric generator, radio energy captured by an antenna, and even biochemically produced energy such as cells that extract energy from blood sugar. The main types of energy are light energy, which comes from the sunlight or artificial light, kinetic energy that comes from vibration, mechanical stress or strain, thermal energy, waste energy from heaters, friction, engines, furnaces, and etc., and RF energy, which is comes from RF radiation. RF radiation is employed to power ID cards by directing high-powered electromagnetic energy to the devices from a nearby source. In addition to energy, it's possible to send information as well. However, the term energy harvesting implies that it is the same device which gets its energy from the environment. In cities and very populated area, there is a huge number of potential RF sources: broadcast radio and TV mobile telephony, wireless network, and etc. The conversion is based on a rectifying antenna constructed with a Schottky diode located between the antenna and dipole. The types of energy harvesting methods include piezoelectric energy harvesting, thermal harvesting, solar energy harvesting, which is a mature technology for large-scale energy generation. Photovoltaic systems are found from the megawatt to the milliwatt range, producing electricity for a wide range of applications. From storage to grid-connected PV systems, the application of photovoltaic in portable products is a valid option under the appropriate circumstances. Outdoors, solar radiation is the energy source of the PV system. Solar radiation varies over the Earth's surface due to weather conditions and the location. For each location exists an optimum inclination angle and orientation of the PV solar cells in order to obtain the maximum radiation over the surface of the solar cell. And next, my friend Awa will take over, and thank you.
first method of harvesting energy is piezoelectric energy harvesting. The piezoelectric is a phenomena that kinetic energy converts to electric energy. A piezoelectric sensor is a device that converts kinetic energy in the form of vibration or shocks into electrical energy. Piezoelectric generator provide a reliable solution by converting normally wasted vibration energy in the environment to usable electrical energy. Even though they can generate a small amount of wasted energy, they are an ideal application that can be used to charge a battery, supercapacitor, or directly power remote sensor system. This energy harvesting is applied in musical instruments when applied pressure on the strings is converted directly into an electrical signal. This electrical signal is then amplified and converted into sound through a speaker. The second method is pyroelectric energy harvesting. Pyroelectricity is the phenomena in which temperature fluctuations in the environment are converted into electrical energy. Pyroelectricity can be described as the ability of certain materials to generate a temporary voltage when they are heated or cooled. The applications of pyroelectricity are heat sensors, nuclear fusion, and power generation. The third type of energy harvesting is thermoelectric energy harvesting. A thermoelectric effect is the direct conversion of temperature differences of electric voltage and vice versa via a thermocouple. A thermoelectric device creates a voltage when there is a difference in temperature on each side. Conversely, when a voltage is applied, heat is transferred from one side to the other side and creating a temperature difference. The application of thermoelectric harvesting energy are thermoelectric generators, just like stoves, fans, smartwatches that are powered by body heat, and filter effect that are used in the laboratory devices used to amplify DNA, and for temperature measurement, just like thermocouples and thermopiles. The fourth type of energy harvesting is harvesting energy from environment. From the first one from solar energy. Solar energy is the energy harnessed from the heat and light of the sun. It's used for generating electricity, water heating, lighting, and transportation and other things. And the third one is wind energy. Wind has a kinetic energy that can be harvested using the power of the wind as a mechanical power. It's used for generating electricity, pumping water, and transportations.
As for the calculation, we have the first equation on the left, thermoelectric energy harvesting. The equation has the following parameters. PMP represents the maximum required power, delta T, the power that's required from the difference of temperature over the resistance of thermoelectric engines or generators. For the second equation, we have a pretty fundamental equation, the Friis transmission equation. It's used to calculate the power received from one antenna with a particular gain, and then when transmitted from another antenna with a particular gain as well. Separated by a distance and operating at a frequency and a wavelength of lambda. The parameters for this equation, PR is the power at the receiving antenna, and PT is the output power of the transmitting antenna. GT is the gain of the transmitting antenna, and GR is the gain of the receiving antenna. Lambda is the wavelength, and R is the distance between the antennas. The equation shows that more power is lost at higher frequency. This is a fundamental result of the Friis transmission equation. This means that for antennas with the specified gains, the energy transfer will be highest at lower frequencies. And the difference between the power received and the power transmitted is known as the path loss. Friis transmission equation says that the path loss is higher for higher frequencies, because simply this lambda represents the basic equation for the speed of light, which in this case wavelength equals speed of light over the frequency, and then when plugging it in, that's the result. And with the third equation on the right, we can calculate the net power output and the efficiency of a thermoelectric generator. Solar energy and voltaic cells, photovoltaic cells are considered to be the future of renewable energy from radiation, specifically solar radiation. The annual energy output of a photovoltaic system can be calculated through the given equation. The solar energy output of a voltaic system, E equals A times R HPR. E represents the energy parameter, which is measured with the unit kilowatt per hour. The area represents the total area of the panel, and R is the solar panel yield. The yield of the solar panel is given by the ratio of the electrical power of one solar panel divided by the area of the same solar panel. H is the annual average solar radiation on tilted panels, and it's measured with the watt per meter cube. PR is the performance ratio, the constant for losses. It usually ranges between 0.5 to 0.9, but the default value for that would be 0.75. So basically there are three devices that would measure the radiation that's coming from the sunlight: periometers, pyranometers, and photoelectric sunshine recorders, which is the less accurate one. The total irradiance, watts per meter square, measured on a horizontal surface by a pyranometer, is expressed by the equation on the right. I total equals I beam cosine theta plus I diffuse, where theta represents the zenith angle between the incident ray and the normal to the horizontal instrument plane, and I is the hemispherical radiation.
There are also some disadvantages to energy harvesting. The cost of an energy harvester can be high when compared with the overall cost of a wireless sensor. It means it is not efficient. Another con, it is not always easy to have a small converter. If we think about the size of a coin cell battery, today it's not easy to build an energy harvester with the same footprint that can provide a useful amount of energy. For the sake of comparison, a typical deep sleep current of a wireless sensor can be around 1 microamp. A vibration energy harvester the size of an AA battery can provide tens or hundreds of microamps at the most, with acceleration of around 1 gram. These values vary a lot depending on the technology of the harvester, on the material used, on the frequency distribution of the vibration, and on their peak to average ratio. Generally, energy conversion efficiency increases with the size of the generator. This is due to several factors, one of which is related to the fact that energy harvesters often produce an AC current which must be rectified. If you use diodes to rectify the current, we have to deal with the threshold voltage of the junctions. These represent an energy loss. The bigger input voltage to the rectifier, the higher is the conversion efficiency. In conclusion, energy is lost or wasted most of the time in the environment, either directly or indirectly. If we can tap into those sources of energy leakage, we can process and accumulate energy that can be pumped back into the system or use it for other efficient work. Energy harvesting systems are the future, and technology plays a crucial role in building such a sustainable system. This is a capture and transformation of embedded energy in the environment into electrical energy by means of transducer, which is used to power variety devices such as consumer electronic, wireless sensor nodes, implementable by sensor and military stuffs. There are 4 types of energy harvesting method, which are piezoelectric energy harvesting, thermal harvesting, solar energy harvesting, and pyroelectric harvesting. The piezoelectric is a sensor device that can convert kinetic energy in the form of vibration or shock into electrical energy. Pyroelectricity is a phenomenon in which temperature fluctuations in the environment are converted into electricity energy. The thermoelectronic is the direct conversion of temperature differences to electric voltage and vice versa via a thermocouple. The thermal energy has a high value when the mass of an object differences over temperature are highly solar energy in the energy harnesses from heat and light on the sun. Energy harvest applications are mostly designed to be self-sustaining, cost-efficient, and available to extend the potential life of the entire system for a long period of time. The benefit of energy harvesting is that the battery-free cloud connected with the wireless sensor allowed enhanced tracking of environment cases in a variety of applications, such as cloud change, data centers, constructions and power, digital framing, and smart healthcare. Energy harvesting can give sufficient power for wireless sensor, embedded system, and other low power circuit, even it is very small and in order of milliwatts. Also, there are some disadvantages, which are the cost of energy harvester can be high when compared with the overall cost of a wireless sensor, and the other con is that it's not always easy to have a small converter. Therefore, we use energy harvesting to convert energy into environment into beneficial electrical power. And thank you very much. Thank you for listening.